Okay. So recently, I got down with two examples of that area and well, probability. Well, finding probability using the X measures and then finding the corporate X measures for a certain probability. In this example here, we're going to be seeing the same thing happen again. We're still under the real normal distribution with selected one subject that satisfies a range of variables measurements for the measures that they're in. Using all the characteristics again, once again. And for the most part, now we're dealing with the situations that are going to be between and above and below our probabilities. So that's what we're looking at for this one. So let's go ahead and see what problem we're dealing with, and let's answer the 3 parts too. Let's answer each one of them. So here we go. This one says pretty much after 1996, quarters were manufactured so that their weights are normally distributed with a mean of 56.7 grams and a standard deviation of 0.06. Some machines are designed so that you can adjust the weights of quarters that are accepted to help reduce the amount of counterfeit coins that are accepted. So the whole point of doing it is because there's a lot of fake coins that go out there, and the machine will put false, will be tricked at the quarters. So you could adjust it so to avoid those. Once again, by avoiding those guys, you also are preventing certain actual legal quarters to be not accepted. Well, because it's based off weight. It's not based off image. It's always based off weight. The machine cannot take a picture of what you're seeing. It determines what it is based off weight. But anyways, that's what we're seeing here. So when we're doing this problem, what we're saying is, if you adjust your vending machines to accept weights between 5.6 grams and 5.74 grams, find the probability that a randomly selected legal quarter will be accepted. Remember, this is a range of acceptance. Keep that in mind. This information about these are the good quarters, and we mentioned about modifying it so that we can have acceptance. So we're saying that this is what you want your limitations to be. What percentage of what the probability of it being selected, aka what will be the percentages if you are at percentage of them that will be selected, that will be accepted. But anyways, let's go ahead and get started with this. So let's just go ahead and start building this, because it's hard. It's very important that we know how to visualize what's happening. We have to visualize, because if you don't see it, just doing it and not understanding where it's coming from, it's going to be very hindrance. And once again, in my exam, I'm going to let you guys know, can you illustrate what's happening? Illustration is going to be key in mind. So illustration is going to be very, very key. So come over here with our markers. This is per dummy. Anyways, so once again, we're looking at the same situation happening over here. So we're seeing our mu come right here. So let me do this in green. So we have our mu, and our mu is supposed to be up here. We already said that once we had a normal distribution, that's good to know. We had a mean of 5.67 grams, which is the mu, and our standard deviation was 0.06. So this is our signal. So, and I put mu in the wrong spot, I'm smart. Mu goes right here in the middle. So we're looking at it being 5.67. Or what's our measurements? What are our measurements? It's weight of quarters. Okay. So we're looking at the weight of quarters, which is in grams, and that is our X measures. So it's good to know what we're looking at here. I'm not looking at these curves, I'm based off the actual measures. So once again, how do we build this again? Well, once again, if we want to get the next one over, I know I'm going one standard deviation. So I know I'm increasing by pretty much one standard deviation, plus over here will be 2 standard deviations increase, or over here will be a 3 standard deviation increase. And that's you can do once again by adding because it's a jump of standard deviation, so it would be 0.06 plus another 0.06 plus another 0.06. You can do this by hand, and using quick calculations on your calculator, or you can do it using the z-scores, which I'm going to do it. I'm using this operations. Standard deviation, once again over here, -2 standard deviation, over here is -3 standard deviation, just do that. So similar idea, -0.06, -0.06, -0.06. Once again, my points might not be noticeable, so I'll try to make it more noticeable over here. I tend to put the little dot. Try to make it a little more noticeable. But anyways, as we're saying here. So if we want to use this operation, we know that we could let this one be the one that contains our z's. That parameters range from -3, -2, -1, 0, 1, 2, and 3. Okay? Those are our standardized values. And we can build list 2. Which in this case will be our x values. And our x values are determined by it being the mean plus the z-scores times standard deviation. I'm running out of space, but I still have the space in the bottom, which is going to be, in this case, the 5.67 plus list 1 times our 0.06. That's what we're doing. So this is what we're going to do, this one, and this is for this two, when we're doing this operations. So once again, doesn't matter which calculator you do it on. I'm just doing one this time. So once again, we seen it so many times. So I'll just put it to the general typical calculator ones, TI-4s and Inspire. I'm going to start with Casio. To come over here for TI-4s, I can go to my stat, edit. But notice how my list one's already there, so I'm not going to modify this one. I already put it in there. When we modify is this 2. So I'm going to go to this 2. Bring down a little bit so you can see it. This 2, and I'm going to clear this by pressing clear and entering. So now it's cleared, and now I'm going to put down the new expression, which is supposed to be, in this case, 5.67, if I'm not mistaken, plus this one, parentheses for this one, times 0.06. So now it's matching with the expression we have on the side. So therefore I could enter and everything is now in place. Are we going to say result? We use the Casio? Yes, we should. And I'm going to use Casio because we get a bigger screen for this one. So I'm going to go ahead and exit real quick, exit out of this. So this one is already set up for me. So I don't have to worry about that, everything's in there. So I'm going to go to this 2, and once again, I'll make sure these are cleared first. So I'm going to go to delete all, which is right here. So I just pressed this arrow, that's all I did in the main menu. I just pressed the arrow, delete all is right here, and F1 for yes, I want to all delete it. So everything's deleted. So now I'm going to go to clear, go to this 2, and now write the expression, which once again is supposed to be 56.7 or 5.67, not 4, 7. Plus this 1, so parentheses, shift 1, and then 1, close the parentheses, and then times it by supposed to be 0.06. Now when I enter it, we're getting the same results. So since this screen is bigger, I'm going to use this one to make it easier for me to see. Let me make this guy a little more nicer. So it was 5.67. Over here it's supposed to be it's 5.61. Then it's 5.55. And make sure the decimals are obvious. Then it's 5.49. So we got that there. Come over to the right, and we'll go ahead and get those guys in here real quick. So we're seeing 5.67 5.73, followed by your 5.79, followed by your 5.85. Okay, so we got all that stuff in here. Once again, you can do it for any of your calculators, so just get your calculator and do it. I'm not worried about that because this is operation works the same thing for all of the calculators. Just work on them, get them done. Maybe I should do it for this other one, the Inspire. I've been forgetting all about your Inspires. I'm so sorry. So come over here. Okay, once again, I assume everyone already knows how to do it. But anyways, want to do this operations. I can make a minute list here if you wanted to, and I can do that, and I can start making my list for my braces. Over here. So I could do actually control my braces in here. I can start making my list right here if you wanted to, which is pretty cool. So I could do -3, comma, where's my comma at? I haven't did for a while. Comma, over here at the bottom, right below pi. So comma, -2, comma, -1, comma, 0, comma, 2, comma, 3. And I could store this, if I want to store it, first get out, and I'm going to store, so control bar, store, and I'm going to store it to this one. I'm just going to make it safe, I'm putting on this 5, because I don't know which one it is, what I have, so I'll put this 5 fine. So I'll put L5, just in case. So now I'm enter it. Okay, it says it has been done. So what I can do here is, now I could do the same expression. So I could do pretty much this, over here I could do, once again, it's supposed to be 5.76 plus, and now I know my list 5 is supposed to be this, so I'm going to get my list 5 in here. So I'm going to put list or R5 in there, times, and I'm going to put the 0.06 in there. And I'm going to store it, make sure I have it stored. So I'm going to store it, oops, wrong one. So let me put it up, escape. Control store, I'm going to store it to this 6. So that's what I'm going to do. Now I enter it. It says, oh, and this 6, I should see this. But the good thing is that the same thing we have over here, it should be the same thing. Okay, we're seeing, it's a little bit off. Can I test something? 7.6, sucker. I gotta fix that. I always mess up with that. I always switch things around when I do things. I do apologize. So once again, I'm gonna re-enter this guy, okay, and then fix it. I'm over here and make some fixing. So over here, it's supposed to be 6.7, not 7.6. So I'm gonna put that in here. So first delete 6.7. Or that should be good. So now I'm gonna re-enter it. So now everything makes sense. So we're seeing the same thing. 5.49, 5.55, 5.61, and on. Okay. Another funny thing, you can do this for all your calculators. You can do this way for your calculators, and you don't have to worry about this thing right here. So it's really your choice how you want to do it. But once again, everything is golden. Everything is ready to go. And I could put this guy over here like I did. Okay. So I'm going to do your list. Go ahead and make your list. It's really your choice. I'm not going to do it. You can make your list from there. But like I said, you can do all your list operations on calculator as well. But anyways, we're good here. So let's go ahead and answer the rest of this question and get it pretty much done. So I'm going to erase this no more, so I'm going to erase this because I'm going to use the space. So let's do part A. Part A says, okay, once again, if you adjust the vending machine to accept weight between the 5.6 grams and 5.74 grams, find the probability that a randomly selected legal quarter will be accepted. So let's get our range of acceptance. So we're saying here it's supposed to be 5.6, which is pretty much this is around, that's about halfway over here. Okay, this is your 5.60, or almost halfway between these two guys. Maybe a little more to the left, but it's just a guesstimation what's happening here. And over here, we're looking at it being at 57.4. So 57.3, 5.73, 5.79. So it's definitely in this range over here. It might be this close to be right there. So what we're definitely seeing is in this range, 5.74. Okay. And the other things you guys can be grabbing yourselves, drawing yourselves, put it in the right spot. We'll guesstimation where it's at. So when we're doing this, we definitely know that my area is within these two. This is the off. Did it again. Okay. So we're looking at this area right here. This is all the ones that will be accepted. Okay. This is your accepted region. Okay. Everything outside in this region right here is rejected region. And over here is also rejected. So what's the probability that it's in the accepted region? That's what we're going to be looking at here. And this is the area we need to find. For the accepted. Because remember, it says they wants it to be accepted, not rejected, accepted. So what we're putting here is, well, our job is to find the probability that our X value is somewhere between, where's it at? 5.60 grams X, or measure X, and 5.74 grams. And this right here could be less than 2. Once again, since it's continuous, that less than 2 doesn't really matter in regards to the calculator. But now, how to write this using, because that's what it looks like in probability notation. So how to write this using calculators to get it to work. Normal is normal distribution. So I'm supposed to be looking for the normal. Okay. So normal CPF, because once again, it's a range. It's not a specific exact answer or value. And it's supposed to be, once again, we have to get a lower, our upper, we need to know our mean, our mu, and our standard deviation. These are all things we need to know. And we pretty much know all that information. We have an upper lower here. We just need to know our mean and standard deviation, and our upper, this is high, upper. So let's go through this guys in. So our lower is supposed to be 5.60. Our upper is supposed to be your 5.74. Our mu is supposed to, once again, supposed to be elastic value again, 5.67. And the standard deviation was supposed to be 0.06. So we put all this into our calculator, and we're getting to a conclusion. And that's what we do. So our calculator should be reading this. Each one of our calculators should be reading this. And each one of our calculators should give the same answer. And that tells you what the probability with error is in between. Error is kind of portable. It is area. Okay. Anyways, let's get back to it. So, come over here. Remember, for this one, you definitely have to be out of, for the conceal, you have to be out of the stats, and you have to be in your run matrix calculations. Oh, I did it wrong. That was the other thing. That's for the calculator, the TA force. So you have to be here. So make sure you know stats, and once again, distribution right here in the main menu. So press distribution, normal, CDF. Once again, variable mode, because we have information, we don't have data, we have all information about the, we have the 1 bar statistics, so we can use 1 bar statistics. So lower limit is not supposed to be negative 10 to the 99, it's supposed to be, once again, 5.60. So I'll put 5.60 there. Upper limit is supposed to be 5.74. So I'll put that there. The R standard deviation is supposed to be 0.06. And the mean is supposed to be 5.67. So we have all the information we need. So we could definitely go ahead and calculate it. But if you want to graph it, you could graph it, and you can definitely see that we should be in performance about the same information, same graph we have over here. Some characters can't graph this, others can. So I'm not going to teach you how to do all the graphing because we should be able to guesstimate on the over there. But my guesstimate would seem to be okay. The only one I kind of messed up on the guesstimation was over here. Okay, it's actually a little more further over here. So all I gotta do is permanently adjust it and put it where it needs to be. Okay, for guesstimation. But anyways, we are golden from there. But what we're saying here, the resulting probability is supposed to be 0.7665. Depending on your book and your instruction, they might ask you to round up a certain way. Typically, in the, I should have thought of this, but in our book, the answer back in the book for normal distribution is supposed to be 4 decimal places. The first time I did it, I did wrong is significant, but significant was key to helping see what's happening. But over here, for 4 decimal places, we're supposed to be permanently seeing 0.7567. Yeah, 7567. So this permanently book does, the book keeps 4 decimal places, so we'll do the same thing. I'll do probably for the other one. This is just ended at 5. But I'll just keep what we have right there for so you can understand how this significant works. 3 significant digits. But anyways, come over here. We are golden, so we have a final answer. So all the other calculators should give the same answer. That's one thing we're going to be saying. All the others should give the exact same answer. So let's see if that's true. So we got this out of the way. So I guess we'll first do the Inspire, since Inspire is right here. Let me just get this guy turned on. So for the Inspire, I'm going to do the same thing. Oops, I'll just calculate now. So we're going to do aim for this guy. So once again, we're going to go to menu, probability, no, stats. Under stats, we're going to go to distribution. Under distribution, we're going to do normal, CDF. And once again, lower bound is supposed to have been the 5.60, so 5.60 for lower bound. Upper bound was supposed to be 5.74. Okay, we got that in there. For mu, it's supposed to have been 5.67. And for standard deviation, it's supposed to be 0.06. So everything's matching. Once again, all this is matching what's said right here for our distribution CDF. So we have normal CDF, lower, upper, mu, standard deviation. So now I'll go ahead and enter it. Okay, we got to go to OK. So we're ending up with the exact same result, 0.756655. So we end up with the exact same approximation to 4 decimal places. So we see that there for your Inspire. So I'm going to move the Inspire out the way and bring out the TI-84 and the silver. And we're going to see something happen. So if your calculator cannot type this in, the information that we have to be able to type this out. And we'll see that for the TI-84. Once again, let me get the color real quick. Okay, the color does have its upsides. So Once again, for color, you don't be here, you want to quit it, so second quit it, and be outside in the calculations. So now I'm going to do the same thing, second distribution. I'm going to hit normal CDF. And once again, right here, it's supposed to be 5.60 for the lower. Upper is supposed to be 5.74. For the mu is supposed to be 5.67. And percentage is supposed to be 0.06. Now paste it. So now once again, this is mimicking what's over here in our information. So make sure that all matches. If not, just adjust it by going inside and making changes that you need to do. And now you can enter it or just redo the information again. It's your choice. And once again, same, very similar answers. Very, very similar answers. Okay. I would say to be exact, but once again, it could be the case that I might have put something slightly different in here, which I highly doubt. So that's your TI-8 for color. And now let's get the one we have to write in, the inspire, and see how that one works. For the, silvers and all the other ones. We have to write in. Okay. So come over here, similar thing. Once again, so second var distribution, go to the CDF, and I'll read this type everything in. Start from the lower, 5.60, comma's the first word. Then we have the 5.74, comma, followed by the mean, which is 5.67, followed by your standard ratio 0.06, close parentheses. Once again, it is mimicking. It's mimicking everything we have that we need. So come over here, enter, and we should end with the same answer. We end with the same answer. Okay. So that's all good. That's all in. Now we could go ahead and jump to the next question. Everything's there. So all we know is that inside here, inside this area region, okay, for the acceptance, all we know is that it's going to be 0.7567, approximately. So let's get to the next question. That comes down to this. We're pretty much answer almost all the good stuff right here. This might need to change a little bit, but we'll see that happen. Okay. So, coming over here. Right here you can find out there's different ways you can answer this question. It's really your choice on how you answer this question. Typically, we already found one information, but you can find all of them individually if you choose to. But it really comes down to how you want to answer the question. That's what it comes down to. And we'll see it right now. Where's the clicker? So, part B. It probably says here is going to all this information. It says what percentage of legal coins are rejected. Okay. So if you didn't notice from before, we found a probability, okay, of getting accepting one quarter legal quarter that actually was accepted. Okay. So what does this mean in percentage? If you want to write this as a percentage, and I'll put it pretty much here on top. What does this mean as a percentage? All we know is that 75.67% of all legal quarters are accepted. That's what it's saying as a percentage. So if we know that, if we know what percentage of them are accepted, we know how much will be rejected by its complement. So what I could be doing here is I want to find percentage of rejection. We should know that it comes from that idea of the probability of accepting. So what we can definitely see here is find the probability of rejection is equal to 1 minus the probability of acceptance. That's what we can definitely see here using complements. And where we know that, we about the acceptance, we know it's going to be 1 minus 0.7567. So I can put this into our calculator and figure out what the rest of it is, which is what I'm going to do right now. So, come over here, I get the use one right here because it's on already. And what I'm going to do here is, let me just first clear this. So what I'm going to do is I'm going to put 1 minus the 0.7567 in, and I'll get this as an answer. 0.2433. Remember, this is probability. My question is not what the probability of I'm setting the subject or a quarter that's going to be rejected, legal quarters will be rejected. I'm asking what percentage of the legal quarters will be rejected. So I have to actually get this one here, change from probability, and times it by 100%. By moving this one over 2 decimal places. So my appropriate answer for this one here is going to be approximately, we're looking at We're looking at approximately 24.33% will be rejected. That's almost half. Okay, so is that really a good? Is that really no? That's almost 25%. So is that feasible? Where you think about in terms of common sense, you might want to have more of those quarters in there that would be accepted, but also keep in mind that you're also going to be increasing the amount of false quarters as well, false coins. So it comes to the manufacturer, and they're the one who debate, okay, how much quarters are we going to accept, how many false coins we're going to accept. Remember, they're not the ones putting quarters in, the people are. So they might use service based on customers, but hopefully the customer has more quarters on them, and they could put more quarters into their machine. So they could lose, they could lose, what we call it, customers because of this issue, okay? Or they could not. Okay? It all depends on the customers and what they have available for them when they input the information. Anyways, the probability still a little high. Is it still high? I would say yeah. And I would want to adjust the system, the quarter machine, to avoid that from happening. That's something I would do. So, because another thing we're kind of seeing here is definitely 24%, because if you're over here, we're looking at around 68% of what are going to fail. And it's a little bit further out there. What it is right here is supposed to be 96%. So we definitely know it's a little bit more than 16%, but definitely much less than 95% of your data that's going to not be accepted. That's what's happening here. So that's one way of doing this problem, because since we already know rejection, well, how many's in the middle, I could just go with this. Okay? Or I could do the range of rejections. Okay? That becomes the choice of the individual. How you want to answer this question. Will it work? Yes. But it comes down to your choice, how you want to answer this question. Do you want to keep to the acceptance that we already know the answer to, or you want to do this one? Okay, go to the other one. But anyways, that won't be too difficult either. I can just find this area, and add them together, which is not too difficult. And you can figure it out pretty quickly, and I'll do it right here below. Right here. I wish you end with the same answers. So this would be alternative. So all we're saying here is our probability of reject should equal the probability of getting a measurement, a quarter that is less than the 0.56. I did it wrong, 5.60 grams. Okay. Plus, because it's an or. Either it's here or it's here. Okay. The probability of that x being some value that's greater than 5.74. There's really a choice on how you want to do it. This is never really seen it. So now I can get those guys in here. But remember, these guys have their own normal distribution. What we're definitely seeing over here for this portion, and I'll put it down here. It's going to be, in this case, I might need more space. So I'm going to put it a little more over here. So I'm looking at it being the normal distribution of it being from -10 to the 99, comma 0.56 or 5.60, 0, comma the 5.67, comma the 0.06 plus the next normal. Okay, so I'll put quotes here for because it's still going to be normal. I need some space, and we're going to have in here your 5.74, comma your 10 to the 99 plus, comma your 5.67, comma your 0.06. Okay? And that's what we could write as an expression on your calculator. Or you could do them individually and add them separately. It's really your choice on how you want to do it. So, let me see if it's even possible to do it over here. It might be possible, you might do them individually, but I know for these calculators, you could do them as individuals, which is pretty good about these calculators. No restriction, no limitation. So, let's say we want to put this calculator here. So, this is Inspire. So, I'm going to do the normal once again. And what I'm going to do here is I'm going to go for this one. So the first one, which is going to be the -10 risen to 99, comma, and it's going to be your 5.60, comma, your 5.67, comma, your 0.06. So that's your first one, plus the next one. So I'm going to do the same thing. So second distribution, normal. Now I'm going to add, that's inverse. Let me put this one. Delete. Second distribution, normal CDF. And I'm going to do the same thing. But now I'm going to start with the 5.74, comma, the 10 to the 99, comma, the 5.67, comma, your 0.06. So now we have this whole expression here. This guy here is mimicking this one right here. It's mimicking it to the fullest. So now when I press enter, oh, right there, dang it. I hate when I do something like that. Dang it. Okay. Shoot. Let me just do it again. I always mess with a damn comma. But anyways, let me do it real quick. This tells you, also for me, always make sure that you are checking your expression to make sure there's no errors within it, or else you're going to have to retype it again, especially for this guy. You have to retype it every single time. Anyways, come over here. Once again, normal. 5.74. That's right. Where should we get this time? There we go. Okay, and that's the same answer we got over here. So this guy is matching with right here. same answer. And we get the same result, in percentage. So once again, it really comes down to your choice, how you want to do this problem. It's really your choice. You can go for the middle acceptance and then do complements, or you can go for the outsides and do the same way. We get the exact same answer at the end of the day. So once again, all the calculators, one thing about this one, you might not be able to do 2 at a time, but that's because we're in data, we're not in a expression calculation. So that's one thing that I'm a little concerned about for this one, because every single time I try to do for calculation and stuff like that, you won't be able to do what we need to do. Oh, look at distribution. Yes, it works. So you can actually do it here. Nice. So once again, if you want to do, instead of doing this under stats, you can do it here under calculation. So I'll show you right now how it works for the conceals. So first thing, you can be in run matrix. So you can be in run matrix, and you just press 1 for 1 matrix, and now you have to press options. And under options, you're going to go to statistics. Under statistics, we see distribution. And now I'm going to ask you which one you want. You want normal. Okay. So go to normal and then CDF. So now you actually make the expression here. That is great. So my concern was you won't be able to do it, but notice over here, you have to, you have to type it in. You have to type everything in. So you won't have the option to put the information in. You got to do the same thing you do here. So just do it here the same way. So just put it in where it needs to be. So looking at negative 10 risen to 99. Why is that there? There we go. Comma. And now we're going to put the same thing in here. And it's supposed to be the 5, oops. First one would be, so the 5.60, comma, the 5.67, comma, the 0.06, close parentheses, plus the next one. So I'm going to do normal CDF again. And over here, I'm going to do the same thing, but no, the other one, so it would be 5.74, comma, the 10, risen to the 99, comma, 5.67, comma, 0.06. So I get everything to see the same thing. If you need to go back, I'll go back, load it back to make sure everything is good. So normal CDF, negative 10, lower negative infinity, 5.60, that's good, 5.67, that's good, 0.06, that is good, plus another CDF of 5.74, that is good, to the positive infinity, but that is good, 5.67, that is good, 0.06, they all look good. So now I'm going to enter it. Okay, it's supposed to be the same thing. Then not put in right. Once again, we just gotta read and understand your calculator, no limitations. It's supposed to be just adding, but let me see what I did. It's supposed to be add. It is. It's add. That's 4. It's 1,000. 6. 7. That is good. Oh, it's the order. I forgot. Darn it. It's the order. Over here is supposed to have been acceleration first. So the first was supposed to be 0.06. I forgot this one has a different order. Okay. Casinos, watch out for that. Know your order. It's supposed to be sanitation than me. I should have caught on to that. There we go. It was the order. That's good to note then. Real good thing to know. Those who have the casino, watch out for the ordering. It's different than the Inspires and all the other ones. So I'm going to write here an arrow for green. Castillo, watch your order. Watch your order. I just found out right now, order matters. And I thought it was only because of the setup that's in the calculator. It's the same thing here. Okay? Dang. I wonder if I would do that. I never did it on the calculator. I was in stats. So I never really learned its limitation until now. But anyways, all the other calculators is going to do that. That's for sure. I do apologize. I didn't know that. I didn't think about it until now. So when you're doing that on the calculating, make sure you have your order correct, or else it's going to be messing up every single time. And that's for those who can see. Okay, guys, those who can see, watch out big time. Those who do the data board, same thing's going to happen. You can do the same setup, the same way I did in Inspire, and it's going to work. But yours has this idea, so you're good. You have nothing to worry about for yours. And then for the Inspire, okay, I would say watch out for yours as well. Let me just see real quick. On. And then see if it's possible. So I'm going to get this to happen. So I'm going to do the same thing. You could either write it in yourself, or you could definitely just do the binomial distribution again. So menu, I'm going to do the same thing. Stat, distribution, normal CDF. Where here's what is with negative infinity. Back to 5.60. Over here, the mean will be 5.67. Center region is 0.06. So all that's matching for the lower limit. So I could enter it, and it shows it there. And then right here, what I could do plus. I could add it. I'm going to add the answer, and now I'm going to do the same thing. I'm going to go to menu. I'm going to do my distribution. Ooh, wrong one. Distribution.